Just a few hours ago, an incredibly large number of pagers in Lebanon, owned by Hezbollah terrorists, began exploding. This is crazy. This is an ongoing, developing story. Reuters is reporting on it. Everyone's starting to get the news. And it's pagers that are exploding and killing and injuring Hezbollah terrorists by the thousands. Last I saw, there was around 1,200 casualties because of these exploding pagers that were all synced up to explode at the same time. Now, we're not going to get into the details of who exactly did these exploding pagers and all of that stuff, but what I would like to talk about is how this possibly happened and what it says about the need for a secure supply chain for both electronic hardware and the software that powers it. This is an issue that really doesn't get talked about quite enough. The reality is, the vast majority of computer hardware that we have and use, I'm not going to scroll down on this page for those watching the video version. I don't want to get into the graphic content here because there's lots of pictures and images out of it, out of this particular event. We'll stay pretty laser focused on the supply chain side of this. If you buy a computer right now, if you buy a cell phone or a pager, and you really have no idea where it comes from. I mean, realistically, you have no idea. And 99% of the time, it does not come predominantly from the country that you live in. Most electronics are, let's say you live in Canada. Most electronics are not assembled in Canada. Even in the United States, most electronics are not assembled in the United States. And the reality is, different components are built in such a wide variety of countries, in a wide variety of facilities, that securing and having confidence in the security of your supply chain for any given, say, smartphone or pager type device is almost zero. It's incredibly hard. And most companies producing this hardware don't make it easy for you to even look into exactly what that supply chain looks like. They keep it closely guarded. If you want to find out what's inside, let's say your Samsung Galaxy class smartphone, well, most of that phone is all glued together, so good luck even getting into the internals. And should you be able to get inside of them, half of the time on these sorts of devices, the individual chips are covered in blobs of glue-like substance to prevent you from removing it, checking the serial numbers on it, and figuring out the exact details of it. It's an incredibly difficult and annoying situation that we find ourselves in. So when you get your laptop, when you get your Nintendo Switch, when you get your iPhone, who has had access to that device up until now? Not including the individual hardware engineers and software engineers that designed it, not even including the specific people across a wide variety of countries and factories that had their hands in developing the individual components, and not even including the final facility where all of those components were combined together and the final packaging was done. Not including any of that. How many people had their hands on your device or the components that make it up? It's a huge number, from the shipping individuals to the people that work in those offices and facilities to the people who simply had access to them along the way. And so it's very difficult for you to know for sure that your device is even as the original manufacturer intended it to be when it gets to you. Now, there are some companies out there, very, very few, who are actually looking into this. Now, I'm going to talk about one particular company here named Purism. I used to be the director of marketing for Purism for a time, and I have not had any relationship with the company for quite a number of years now. I have several concerns about this particular company's business practices and products. However, it is one of the few companies out there that is actually looking at the supply chain related issue. And if you go over to Purism's website, which is puri.sm, and you look through their blog, you can find one on protecting the digital supply chain, which talks about how you can protect it, problems with this digital supply chain, issues with the supply chain related to your firmware, and how many attack vectors there truly are for someone who is thinking like, I'm going to modify this hardware, add spying hardware, add explosives, like in the case with the pagers, to the hardware before it reaches its final destination. Now, the reality is, this company, Purism, is attempting, at least in some of their products, to add some supply chain security. But even then, it's incredibly limited. And even with them attempting and putting forth a good faith attempt, and I can attest to the fact that they are putting forth a good faith attempt at securing their hardware supply chain for one of their devices, it's still nearly impossible. Case in point, the Liberty phone. Many years ago, Purism released what they call the Librem smartphone. It's a Linux-powered, somewhat repairable, somewhat modular phone. You can open the darn thing up and replace the battery, and there's switches where you can turn off, physically disconnect the wireless and the microphone and all sorts of things, which is a very, very cool set of things. Eventually, they decided to release what they call the Liberty phone, which is an entirely made in the USA, in theory, asterisk, footnote on that one. We'll come back to that in a moment. Phone that was a version of that Librem phone that was assembled in the United States. And here's the key. Let me scroll down a little bit here on their supply chain, their page. They said, quote, the Liberty phone adds a highly controlled, secure supply chain. Okay. Now, they go through a number of steps to make sure that that's the case. They do the final assembly of the phones at a secure facility in California, and then they ship them to individuals across the country with some additional protections in place and some ways that you can tell that the package had not been modified since it left the facility and those sorts of things. And that's excellent. However, there's a distinct problem here in that when you build pretty much any consumer electronic, smartphone, etc., those chips inside of it, from the baseband modem, the cellular modems and chips, the Wi-Fi chips, the CPUs themselves, the RAM, all of them. There's a lot of different components in there. Those are made in a wide variety of different countries, not the USA, and in a wide variety of factories controlled by a wide variety of companies. So having full control of and full knowledge of exactly what is in those chips, exactly what software and firmware is powering those chips, and there's a number of different pieces of firmware inside of them, is almost impossible. Almost completely impossible. Like in the case of this Liberty phone, the Purism smartphone here, right? While they make a good effort to have the software powering the phone be predominantly open source and even free software in this case, there's a lot of software and a lot of hardware design inside the phone that is very much proprietary, locked down, and that the company building it, Purism in this case, does not even have access to, right? So it is almost impossible, even in this case, when a company is really working hard to secure the supply chain, to actually secure the supply chain. Now, in this particular case, with this Liberty phone, it probably is not going to have an explosive in it because, well, they've taken steps where from the point of the phone being assembled until it reaches you, they try and secure that supply chain. Right? So you can have a certain level of confidence that after it left the facility where it was assembled to when it got to you, it probably hasn't been tampered with. That's good. Probably no explosives then. Assuming you trust Purism, right? It requires a level of trust along the way and along every step of the line. But that still means that software is a distinct issue, and along with the hardware. But let's put the hardware aside. Let's put the hardware aside for a moment, and let's talk about software, because the digital supply chain of software is just as problematic and difficult to secure. Many years back, I made a video. I made a video. This was back in, I think, 2018. Yeah, there it is, 2018, called HTTPS is dangerous, right? And this was a video I made. You can watch it over on my locals, lunduke.locals.com. It is a video I made purposefully poking the beehive, right? Because the point of it was very simply that HTTPS has some very significant problems, including problems doing the core thing it was supposed to do. Because HTTPS is secure SSL wrapped HTTP requests. The idea being that from the connection between the server and the client is secured, right? So no one can hijack it. If you don't use HTTPS and you just use HTTP, plain old open text HTTP, it's very possible to do a man-in-the-middle attack where, let's say someone connects to my Wi-Fi hotspot, and my Wi-Fi hotspot is using a custom firmware, and when they attempt to go to a website, I can begin injecting content into those HTTP packets going back and forth. And that means I could do all sorts of things. I can modify the web pages that you see. I can modify and see the contents that you're passing back and forth, passing around passwords and login information. I can see all of that, right? So there's a great number of concerns with just using plain HTTP. However, HTTPS, while it somewhat solves that, there are known backdoors into it, including an NSA backdoor relating to the certificates and other ways to kind of circumvent a great deal of that. And all of that comes at the expense of a complete loss of backwards compatibility with devices that don't use the current version of that SSL encryption, which really is out of date every couple years. So if you use an older web browser, you can't use the internet anymore, and that becomes an issue. And then on top of all that, you still have to have a certain degree of trust, right? Because all of this is built on a level of trust. In order for HTTPS to work, we have to have trust in the companies and organizations that are signing and creating digital certificates that certify those connections. Because you ever go to a website that's an HTTPS website and their certificates expired, right? Those certificates come from somewhere. Those come from certificate authorities. You have to have trust that those signing authorities are going to be always 100% of the time acting in your best interest, you personally. And that means that at no point is any person working for those certificate authorities acting in a nefarious way. One person spoils everything. One bad apple spoils the bunch. In addition to that, that also has to have a great deal of confidence in there not being technical issues, loopholes, backdoors that can be used within those certificate signing processes. And so it's a lot of faith. Our whole system of both software and hardware supply chain is based on faith. The same is true for certificates and signed applications, whether you're using Android or iOS or Windows. Applications, Mac OS now has application signing. You get these signed applications, right? The developers have to use a certificate from a certificate issuing authority and have to sign their applications so that when you get it, you have some level of confidence that that application is as the developer intended it. That's the binary the developer created. It is for you and no one has tampered with it, right? In theory, that's all great, and it does go a fair distance towards solving some of the supply chain issues. However, it again relies entirely on faith in the developers, faith in the secure supply chain, faith in the certificate issuing authorities, faith in the developers working on all of the encryption and certificate creation systems along the way. There's a ton of faith that has to be involved here. And so the reality is, even though We have companies like Purism trying to create a secure digital supply chain, and we have a lot of software supply chain attempts that have been made to really get that secure. We don't really have a fully secure supply chain for either software or computer related hardware, including pagers and smartphones and laptops and everything. We don't have that right now. Not at all. When you look down at your laptop, at your smartphone, whatever you're watching this on right now, do you know everything that's inside of it? No, you don't. You probably don't. Even in the examples of, let's say, a Framework laptop. Framework's a great company producing these laptops that are fairly modular and fairly self-repairable compared to other laptops. Not perfect, but better by comparison. And even in those cases where you can open up the laptops and you can see the main board and there aren't a million globs of glue on every chip here and there, you really don't know what all is going on there, right? You don't have a full high level of confidence. Do you know the firmware that is running on all of those chips? Does Framework know how all of the chips in their laptop is working? No, they don't. They absolutely do not, because they did not make those chips. They bought those chips from another company in another country, working at a different factory that they did not watch 24/7 and have an active hand in the development of. Therefore, you don't know what they do. That's the reality. A really great example of this is the IME stuff that came out of Intel, the Intel Management Engine stuff, where the higher end Intel chips, like the i7s and whatnot, they had a second CPU inside the CPU, right? So when you have your i7 class computer, inside of it is a thing called IME, and it's a 486 class CPU that is running a version of the Minix operating system that has a web server in it, an FTP server in it, and all sorts of stuff. And it has full what is called ring zero access, meaning it has access to every little bit and byte in your computer, everything that goes through your CPU, all of your memory, and unencrypted, full access. Now, Intel has access to that. Intel created a CPU hidden inside your CPU with a web server that has full access to everything that's in your memory. Say what now? Now, this is common knowledge, and many companies have gone through efforts to deactivate the Intel IME. System 76, another hardware maker, they made a big splash about talking about deactivating the IME and how they do it on their machines before they leave the factory, if you want, and like all sorts of things like that. And that's great. However, all of this is reliant on us knowing about these sorts of exploits, these sorts of backdoors, these sorts of hidden pieces of functionality inside of our computers, which a hidden piece of functionality, by the way, could be anything from an Intel IME thing where it's a web server. Why would a web server need access to every piece of RAM in your computer, every bit of data in your computer? Why would they need secret access to that? Or it could be a bomb. I mean, that's a feature, right? A bomb is a feature, right? It's a hidden feature. So we don't have any level of confidence in our supply chain, hardware or software, at this point. And the difficult thing here is I don't see how obtaining that level of security, that level of confidence in the security is possible outside of having all of the chips and all of the assembly done in one place, right? And at this point, computers have simply grown to be too complex to make that even close to feasible. And they've grown too interdependent on companies in 27 different nations. I don't see how it's physically possible to secure the physical supply chain, and securing the software supply chain is like chasing a dragon that's high on meth. Like it's not going to go well, and at best you're just going to eventually grab this wigged out dragon's tail and just hold on for dear life. And that's where we're at with things like HTTPS and application signing. A certain level of security can be achieved, but never 100%. It's just not possible. And in fact, as the hardware and the software gets increasingly more complex with more components, with more attack vectors and more eyes on it and more people involved in it and built at more locations, it would become increasingly less possible to secure the supply chain hardware and software for all of it. There's no magic bullet here. There's no special piece of functionality that someone's going to invent, that some piece of software is going to magically make the software supply chain just bulletproof. There's no one good best practice that we're going to suddenly implement, and all of a sudden your Galaxy S-class smartphone is going to have a completely end-to-end secure digital supply chain, or secure supply chain, where you have 100% confidence in every person involved, every step of the process. It's not going to happen. It's just going to keep getting worse. And so the reality is, this exploding pagers incident where the Hezbollah terrorists were attacked with exploding pagers, clearly, we don't know the details yet, but it would look to be that someone intercepted that supply chain, modified the pagers, and added new features to them. And it's almost amazing that isn't happening more. And as soon as you say those words, you start to think, is it happening more? And we're just not knowing it? It's worth thinking about. I want to say thank you to all of the subscribers to the Lunduke Journal. Thank you for making this all possible. Lunduke.com, lunduke.locals.com. And with that, ladies and gentlemen, boys, girls, nerds, and nerdettes across the inner tubes, I do declare, end broadcast.